Hello students, in this session we will take the introduction of Bitcoin scripting language. We are not supposed to study this language in detail. It is beyond the scope of this subject. We just have to study what is Bitcoin scripting language. Of course, we will try to learn what are the properties of this Bitcoin scripting language. So in previous session, we have studied what is outputs, what is input, then locking script and unlocking script. These things we need to understand before learning the Bitcoin script language. So those students who have not gone through the previous session, so I kindly request first you listen the previous session, session number 16, and then try to learn the Bitcoin scripting language. So this Bitcoin scripting language uses a stack based it uses a simple stack based language called script to develop or to describe how bitcoins can be spent and transferred from one address to the another address. So this language is not Turing complete. That means there are no loops in the Bitcoin script language. So there is no possibility that the program will go into the infinite loop because such types of loops are not there in the Bitcoin script language. So this scripting language is based on Forth programming language. The syntax is like Forth programming language syntax, and it uses a reverse polish notations in which every operand is followed by operators, and these commands in the Bitcoin script language are evaluated from left to the right using last in and first out stack. So script use various opcodes. Script has opcodes, and opcodes are nothing but the instructions or commands. That commands will operate on the operands. There are some operands, and operands are pushed onto the stack or they are popped from the stack. The whatever the data uh, is needed during the execution of program, all that data is either pushed or popped from the stack. We will try to learn this. We will not have to go into the details of this Bitcoin script language because we have only one point in the second unit, Bitcoin script language. So we have to take the introduction, what are the properties, then we have to see some opcodes, and we have to take one example how this Bitcoin script the command works. How we will see some one example how the Bitcoin opcodes will use the stack to store the data. So Bitcoin scripting language is a Turing incomplete language. A Turing incomplete language means uh, they have the limited functionality, and this language is not capable of making jumps or no loops. So hence they cannot either, they cannot have the endless loops, or we can say this language cannot have the infinite loops. There is no chance that the program will go into the infinite loop. So being Turing complete means that the given resources and memory, a Turing complete program will be able to solve any problem. Any problem can be solved by this language. There are simple instructions, commands, and there are no loops in this language. This language uses reverse polish notation. So reverse polish notation is a system where the operators follow the operands. You can see the meaning. If we have the operation 3 plus 4, then this operation is written as 3 plus 3 4 operators first and then operator. You can see. So you can see the next example 5 into 3 plus 4. So we have operators, operands first and then operator. Then operations are stack based operation. Data, the commands, whatever the commands are executed by this Bitcoin script language. This command will either push the data onto the stack or either they pop the data from the stack. So fundamental operations of stacks are push, pop. The stack has the data structure which has the property first in and first out. Everyone knows the stack. There is no need to say more about this stack. Then this is a fourth, this language Bitcoin script language has fourth programming language like syntax. This fourth programming language family has the properties rapid development, lean code and super performance. So Bitcoin scripting design goals. What are the goals to design this scripting language? So this scripting language is built for Bitcoins. This is language is inspired from the fourth programming language. The syntax is like the fourth programming language. The codes are simple and compact, and it supports for cryptography. Then the operations are stack based operation, and then this language, this script requires minimum time, very low time to execute, and they require the less memory also. And the main most important advantage of this scripting language is that no looping. This language is Turing complete. Bitcoin script is not Turing complete. It is Turing incomplete language. That means no loops are used. So there is no chance that the program will go into the loop. The advantage is that no infinite looping problem in the Bitcoin scripting language. So in previous session we have studied a lot of things about this scripting. The script consists of outputs and inputs. Then script also consists of locking script and unlocking script. So script is a non-mini programming language used as a locking mechanism. This script is nothing but a locking mechanism. As we have seen, the outputs are locked and unlocked. These are the two fundamental operations on the outputs, lock and unlock, that we have seen in the previous session. So locking script is placed on every output. So every output has the locking script, and when the output will flow from one transaction to the another transaction, then with that output there are two things, locking script and unlocking script. Locking script is placed on every output, and unlocking script is required to unlock the output. Until we unlock the output, this output cannot be used. These outputs cannot be utilized. As we know that outputs from the previous transaction are used as an input for the current transaction. Output from the previous transactions are used as a input for the current transaction. This input will process the output, and they will produce the output for the next transaction. So we have to unlock the output, and for unlocking the output we need the unlocking script. So where the script are in the Bitcoin? So there are two types of script when we do the transaction: script, locking script and unlocking script. These scripts are written using the Bitcoin scripting language. That's why we are studying this language, because we have to do the transaction with this Bitcoin scripting language. If the transaction is valid, if the script is valid, then there must be a two script, a locking script and unlocking script. Then that transaction is valid, because locking script specifies the conditions. When that conditions are met, then that output can be used, and unlocking script is required to unlock the outputs. So first we have to unlock the outputs, and then we can use that outputs. We can do some operations on that outputs. There may be a number of outputs in a transaction. The one address, one address may have number of outputs, and if we want to transfer some bitcoins, then we need to combine these outputs. If we need the 10 bitcoins, and if 10 bitcoins are not available in a single output, then we need to combine the outputs in such a way that we will get the 10 bitcoins, and from that gathered output, combined output, we can send the 10 bitcoins to some other address. So in previous session we have lots of discussion about this, detailed discussion. So if a full script is valid, if when the script is said to be valid, when the script have locking script and unlocking script, when there are both type of script, then that script is said to be full script, and that script is valid. The output is unlocked. First we need to unlock the output, and then we can spend that output. So output can be spent. Outputs, whatever the outputs received from the previous transaction, that outputs can be spent by the inputs. Outputs from previous transactions will be inputs for the current transaction, and this input, on this input some operations are done, and then they will produce another output for next transaction. So what is the script language? A script is a very basic programming language. It consists of two type of things. First, data. Data may contain the operands. They may have public keys, signatures. Then opcodes. Opcodes are nothing but some commands, some instructions, simple functions that operate on the data. These opcodes will operate on the opcodes, specify the operation. What type of operation we have to perform, that operations are specified by the opcodes. So if a full script is valid, if the script has both locking and unlocking script, then the output is unlocked, and that output can be spent. How the output can be spent, we have seen in the previous session. The output is spent by the inputs. Whatever the outputs received from the previous transaction, that output is spent by the inputs, and after spending, after doing some operation, what operation can happen in the Bitcoin? Transferring the Bitcoins or either receiving the Bitcoin. So when such type of operation will happen on the outputs, then they will produce another output, and that output will become the input for the next transaction. So Bitcoin scripting language consists of 256 instructions. Each instruction is represented by 1 byte. 75 instructions are reserved, and 15 instructions are disabled. Basic arithmetic or basic logic, if then conditions can be used, but there should not be loops. Then there are only two possible outcomes of a Bitcoin script. Either script is valid or either invalid. So executes there are only two possible outcomes of a Bitcoin script. The script executes successfully. You can see there are only two possible outcome. First is the script executes successfully with no errors, and transaction is valid, or either script is not executed properly, error while execution, and transaction is invalid and should not be stored in the blockchain. If the transaction is invalid, then that transaction will not go into the blockchain. Block is not created and block is not added in the blockchain. What is blockchain? Blockchain contains outputs and only outputs. So we know that there are outputs in the blockchain. Input is a temporary thing. Input is a processing. Input means we have the outputs from the previous transaction, and on that output some processing is done. That is nothing but the inputs. The inputs will spend the output and then they will produce the output, and these outputs are again stored onto the Bitcoin. So Bitcoin network can be thought as a file. Bitcoin ledger can be thought as a file that contains a outputs. Outputs are different states. Initial state, then these outputs will be modified as the transactions are done in the Bitcoin network. So how do you run the script? The complete script, the script which contains locking script and locking and unlocking script. The script that contains locking script and unlocking script, that script is said to be a complete script or valid script. The complete script is run from left to right. As it runs, it makes use of a data structure called a stack. So you can see the figure. So this data is always pushed onto the stack, either pushed or either popped from the stack, and you can see there are some opcodes. Some opcodes are shown in the figure. These are the different opcodes. You can see this is duplicate opcode. You can see the opcodes in the figure, duplicate, then other opcodes are there, hash 160, which will compute the hash value, equal verify, it will compare the data. Then you can see the check signature, will check the. So these are the different types of operands in the script. So in this single script there are 4 operands. You can see this duplicate, hash 160, equal verify, and check signature. So we will see the examples of this opcodes up in the next slide. We are not supposed to learn this language in detail. We will have to take the introduction, but those are interested in programming, those want to become a Bitcoin expert in future, so you can go into the details of this scripting language. You can find the different sources on internet. There are different YouTube videos. From that YouTube videos and resources, you can learn the script, this Bitcoin scripting language. So what makes the script valid? Script is valid if the top and only element left on the stack is 1 or greater. If there is only one element left on the stack which has a value 1 or either greater than 1, then that script is said to be a valid script. And when the script is invalid, if the final stack is empty, if this stack is empty, then you can see if the stack is when the script is invalid, when the final stack is empty or the top element in the is on the stack is 0. If top element on the stack is 0, script exists prematurely. If the script terminates prematurely, then that script is said to be invalid script. So how script is evaluated? So in previous session, this is nothing but how the transactions are done with the scripting language. So in previous session we have studied detail. In books, if we refer the books, in books some books don't use the terminologies like locking script and unlocking script. For unlocking and locking script, they have different words. They use the different terminologies. And if you see in this example, this is this slide, whatever we have studied in the previous session, that contents are summarized, how the transactions will happen using this scripting language. We know that script consists of outputs, inputs, then locking script and unlocking script. We have seen the purpose of this locking script, unlocking script also, and we have seen what is output and input in the Bitcoin network in previous session. So you can see transaction script. You can read this slide, how the transactions are evaluated. A transaction script is evaluated by combining the script signature and script public key. Now students, this script signature and script public key, these are the terms used for locking script and unlocking script, what we shared in the previous session. This script signature is unlocking script and script public key is locking script. So in this book, the book which we are referring for preparing this subject, Mastering Bitcoin Technology by Imran Bashir. In that book, instead of using the words locking script and unlocking script, they have used the word script signature and script public key. So this script public key, the script signature is unlocking script. You can see the script signature is unlocking script, and whereas script public key is the locking script. So to if the script is said to be full script, if the script is said to be valid script, then that will contain locking script and unlocking script. So locking script is on output, every output has the locking script, and unlocking script is required to unlock the outputs, to spend the outputs. If we want to spend, if we want to use these outputs in the current whatever the outputs we have received from the previous transactions, if that output we want to spend, then we have to first unlock that outputs, and then we have to check the locking script as condition, that has it will contain the address for which transaction is intended. There are some other conditions, that conditions are verified, and if that conditions are met, then the operation is performed on the outputs are spent. So you can see what are the steps to process the transaction. So this is how a transaction to be spent is evaluated. So there are 4 steps. You try to understand these 4 steps. So first step is first it is unlock and then it is spent. So first we have to unlock the outputs. First the output is unlocked and then that output is spent. Then the second step is script signature. Script signature is nothing but unlocking script. For unlocking script, in this book the script signature word is used. So script signature is unlocking script, and this unlocking script is provided by the user who wishes to unlock the transaction. The user who wishes to unlock the transaction, that user will provide this unlock script, and then script public key. Script public key is nothing but the locking script. It is a part of transaction output. We know that each transaction has locking script. This locking key contains the public key, and this locking script contains also a conditions, and this locking script also specifies, you can read it, this locking script also specifies the condition that need to be fulfilled. So the condition needs to be fulfilled in order to spend the output. If we want to spend the output, then whatever the conditions are specified in the locking script, that condition need to be fulfill. If that conditions are fulfilled, then in other words, the outputs are locked by the script public key, or you can say locking script that contains the conditions, and when the conditions are met, when met, will unlock the output. When these conditions are met, that output is unlocked, and that output can be used by the inputs, that outputs can be redeemed. So this is how the script is evaluated in Bitcoin scripting language. So there are two types of script. That scripts are must. If that two script, unlocking script and locking script, will make the valid transaction. So we will see some commonly used opcodes. There are number of opcodes. It is not possible to go through all opcodes. This is beyond the scope of syllabus. We just have to take some examples. In fact, we have only one topic, script language, and we have to take the introduction. But we are trying to explore whatever possible about this scripting language. So that students, I am explaining 10 points. I am expecting that students at least will remain 4 points about this scripting language. That's why we are trying. We are going beyond the book. Whatever the contents are given in the book, beyond that contents I am trying to explain. So there are some commonly used opcodes. You can see opcode duplicate. First opcode duplicate. This opcode duplicates the top item on the stack. Whatever the item is on the top of the stack, that item is duplicated on the stack, and it is pushed onto the stack. Then hash opcode hash 160. It hashes the twice. As we know that in Bitcoin there are two types of hash functions are used, hash 256 and RIP AMD 160. So it will calculate hash value twice. Then equal verify opcode returns true if inputs are equal. If both inputs are equal, then it will return true, otherwise false. Then check signature. This check signature will verify the signature, checks the input signature, check that the input signature is valid during the input public key for the hash of the current transaction. Then check multiple signature. We know that there are some transactions are signed by the multiple private keys, and in that case we have to check m out of n signatures. So this check multi signature checks that if signatures on the transactions are valid from so m out of n as the specified by the public keys. Then check signature. You can see this opcode. Then of equal. So this returns 1 if the inputs are exactly equal, otherwise it will return false. So these are the only examples. There may be different, there are other different opcodes also. Those are interested in programming, that students go and find on the internet, and they will find the some examples of how the script is written, how we can write the programs by using this Bitcoin scripting language, locking script, and there are two types of script, locking script and unlocking script. So there are different types of transactions. So there are two types of, basically there are two types of transactions, standard transactions and non-standard transactions. You can see there are two types of transaction, standard transaction and non-standard. So this we can write, we can perform simple operations, simple transactions by using the scripting language, or either we can have complex transactions can be done. So basically there are two types of transactions, standard transactions and non-standard transactions. Standard transactions are evaluated using each standard function, and there is a function to check whether the transaction is standard or not. Each standard transaction a test, and it will allow only the standard transaction, but non-standard transactions are also allowed, also valid, and these transactions are also allowed. So there are different types of standard transactions. You can see these are the different types of standard transaction. Pay to public key hash, this is one of the standard transaction. Pay to script hash, then multi signature, then pay to public key, then null data or operand return. So there are these are the different types of standard transactions. There are 5 types of standard transactions. So we will not go into the details of these transactions. If students are interested, then you can go. We are not supposed to go into the detail. So you can see one script command is given. Pay to this public key hash. You can see. So this script is shown in the figure. You can see how this script is executed and what will happen to the stack, that is shown in this figure. So you can see this script has some operand, of course. You can see the of course this signature, then public key, then of course duplicate, then hash 160. We will calculate the hash value twice, first by SHA 256 and then next by RIPEMD 160. Then this public hash, then it will this will check whether the operands are equal or not, operand equal verify, and then check signature. So these are the different types of commands, different types of commands that are executed in this script, in this command. So we will see the first command is this signature. You can see this first command, signature, it will push the signature onto the stack. Then second command is public key. So you can see how the values are pushed onto the stack. It will push the public key. Then this duplicate command, you can see it will duplicate this value. So you can see this value is duplicated, one more value is there on the stack, and it will duplicate the previous value. Then you can see next is calculate the hash 160. It will calculate the hash twice. So you can see hash value is calculated, public key hash, you can see there. Then next command is again public key hash. So it will calculate the hash value of this operand. Then next command is equal verify. It will compare these operands. It will compare these operands, two operands, and it will return true or false. Okay. Then it will next is operand check signature. So it will check the signature. You can see this signature and signature from public key, and it will return true or false. So you can see how the this script commands are executed, how the script transaction. This is the one example what will happen to the stack when we execute the command. So students, thanks for watching this session. In this session we have studied the scripting language. We are not supposed to go into the details of the scripting language. We have only one topic, but we have taken the details of this scripting language. We have studied some operation code also. Then we have studied what is locking and unlocking script, and then what will happen to the stack when some transaction is executed, some script command is executed. So there are 4 properties of this scripting language, as we know: Turing complete, fourth programming language, this is stack based language. So from programmer point of view, the scripting language is very important. If we want to go into the details, we need a separate subject for this scripting language, but this is not possible. This is beyond the scope. But those students those are good in programming and interested in writing the programs, they can go onto the internet and find more information about this scripting language. So thanks. So in next session we will study the Bitcoin network. So we will stop here. Thank you. Goodbye.